Alright, so in this video we'll talk about the triangle rule of vector addition. The triangle rule for, well, vector addition. Right, so what is the triangle rule for vector addition? Now we know that if we have two vectors, say vector A and vector B, in this order, say we have vector A that is described as follows, and say it is 5 units in length and it's in the east direction. So if this is our east, north, this would be south, this would be west, and let us have our B vector, B, say in this direction, northeast, and say 7 units. So let's write it like so. So this is vector B, so a capital B with an arrow on top, and let me write the detail of this vector. So it's 7 units in the northeast direction. So it's somewhere along this. Now we want to know that what happens if we apply both these vectors at the same time. Now these vectors at this moment could be anything. They could be velocities, they could be two velocities, they could be velocity of a car moving in the east direction by say 5 meters per second, and B could represent, B vector could represent velocity of another car at 7 kilometers an hour moving in the northeast direction. Could be something like that. It could also be displacements. Say if a person chooses to go 5 units in the east direction, that is, it follows the direction of A, so 5 units here, and then it chooses to go, well, 7 units there. So if it does this afterwards, then we're asking ourselves that if the person initially starts from, say, the origin, goes to point A, that's the length OA represents A vector, and then from A it goes to B, and by that we mean the length AB, if it were a vector, would have been same as B vector. So we're asking ourselves, what's the final position? What happens if both of them are applied? What happens if they act in simultaneity? That means we're asking ourselves, what happens if we combine them? What is A plus B? Well, it turns out it's very simple to look at it in terms of displacements. If we go 5 units in the east direction and 7 units in the northeast direction, then the total displacement should be, well, final minus initial, so that should be this. It should be OB, so OA vector plus AB vector should be, well, OB vector. And that is what we call the triangle rule. Now, even if we don't completely agree with this statement, which shouldn't be the case, but even if we don't agree with it, we actually test this on many other things. We test it on velocities, we can test it on forces, we can test it on accelerations, all of them being vectors, and it turns out that that is indeed what actually happens. So it's like saying if a car has a velocity of 5 meters per second in the east direction, and the car also has another velocity of 7 meters per second in the northeast direction, then in totality the car will be moving in the direction specified by the combined vector of A vector plus B vector and the corresponding magnitude. And that is given by your triangle rule. Now, I'm going to write the triangle rule now, and if I get rid of this, we'll try to work out what A plus B is. So, and try to ask ourselves, why do we have the triangle? Why is it called the triangle rule in the first place? So, if we have a vector A, like so, which is in this direction. So we know A has the same properties as what we drew earlier. So that's 5 units in the east direction, and our vector B points in this direction. So that's 7 units. So let me draw that a bit longer. So let me have. So this is 5. 7 would be somewhere there, right? So that's our vector B. We want to ask ourselves what A plus B is, and the discussion we've had so far should convince us that A plus B would be the vector that originates from the base of the first vector, the base vector, which is A, to the head of the final vector, which is B. So it should be along this line. That means it should be this vector right there. So this is our vector of A plus B. So this is A plus B vector. So this is what we call the triangle rule of vectors. Now, if we go back to what a vector is, we can now give a very formal definition to what a vector is. So a vector must be something that is a physical quantity that has a magnitude, that has a direction, and that satisfies the triangle rule. So I'm going to write it like so for brevity. So this is the triangle rule, which is this. That means if you add two vectors which have a direction and a magnitude in this order, then the resultant is also a vector which has a direction and magnitude specified by the triangle rule. So that is key in defining a vector at this stage. So using the triangle rule, we have established a definition to what a vector is. And we've also specified why it's called a triangle rule. So it's a triangle rule because if you form two sides of a triangle with A and B, the first two vectors, then the resultant vector turns out to be the last side, the other side, the remaining side of the triangle. And that is what I've done here as well. So that's the triangle rule. Now, you may be wondering, well, if this is the triangle rule, right, and this gives us A plus B, then there's no reason for us to think it would be any different from B plus A. That is, I want to ask myself, is A plus B the same as, I'm questioning whether the equality holds, if A plus B is the same as B plus A, this is what I'm trying to question. So let's actually look at it in a bit more detail, right? So here we have, if A plus B looks, if this is what I call 1, and this is what I call 2, then this picture here denotes everything that is specified by 1. So this is A, the first vector, B, the second vector, and I add them up, join them in that order to get A plus B. Now, what happens if I add B to A? So I have B first. Let me draw B first, right? B would be somewhere like this, right? So that's my B vector. Now, remember that if this is the B vector, that means it's parallel to this arrow here, because this also represents the B vector. Not only that, it's also the same in length, because it's the exact same as B vector. So this is my B vector. Now, I need to add A to this. So A would be drawn after this. So from the head now, as exactly where we placed B before, we're going to have A in this direction. So that's in the east direction, and that is our vector A. Now we want to ask ourselves, what is the resultant of this particular combination? And it turns out the resultant would be nothing but the vector that starts from the base and ends at the head. So the base of the arrow is here, and the end should be somewhere there. So this should be B plus A. Now again, this is the picture for part 2. That means this part, B plus A. Now we want to ask ourselves whether this blue line here and this yellow line here are the same. And to do that, it really helps if we draw this picture, whatever I've drawn in 2, on the picture in 1. So to do that, what I'm going to do is I'm going to take B from here and I'm going to draw it from here. Now, it doesn't matter where you're placing your vector. Now, if I have my B vector here, it doesn't really change anything if I sort of transversely move this vector. All I care about is the fact that the vector, whatever it is pointing in the same direction as it were pointing before, and also the fact that it has the same magnitude. So as long as I have those two criteria filled up, I don't really need to be worried about in terms of where I'm orienting my vector, not how I'm orienting my vector, right? So I'm going to take this B and I'm going to move it here. So this would become my B vector. So this blue line here, or just to kind of keep track of the colors, I'm going to draw this in, well, this browny orange color, same as what I did here. So this is B vector. Again, it's the same as this vector. And when two vectors are the same, they are parallel. That means this line, this green line, is parallel to this line. Not only that, they're the same vectors. So that means the length of these two lines are the same. Now, if they are parallel and the lengths are same, that means if you choose to join their heads, they should be parallel to the line joining the bases, because that comes from the property of a parallelogram. So opposite sides are parallel, which is in this case, well, at this point we have proved that it's trapezium because only these two pairs are parallel. But if it turns out that if you do that, if you join the two heads, you get a red line, and the red line must be parallel to the line joining the bases because B and B are identical. That means these two lines are parallel as well. I'm going to have three arrows here to ensure that these two are parallel, not this with this. So these two pairs are parallel, these two pairs are parallel. That means this is a parallelogram. Good. So if it is a parallelogram, and this represents nothing but vector A, and why is that? Because this line is parallel to the base, so it points in the same direction as vector A. Also, because these two lines are identical, that means it cuts this line exactly at the same length as this line. That means, again, these two pairs are not only parallel, they're also on the same length. So basically what we've drawn with our two vectors is a parallelogram. And if we look at the bottom triangle here, we get A plus B, which is this diagonal. That means if we add this base to this side, we get A plus B. But like I've done before in the diagram 2, if we add B and then we add A to that, we get B plus A, and that's also the same as this diagonal. So if this diagonal were A plus B, it's also B plus A. And that comes out just because we're looking at the upper half of the parallelogram. That's what we got in part 2. Therefore, this question mark indeed vanishes, and we have the following rule. A plus B is exactly equal to B plus A, because they represent the same diagonal of the parallelogram. So again, so that was in its entirety the triangle rule, which also morphs into the parallelogram rule, and that is the rule of vector addition. So in this video, what we talked about were 3 points. We talked about that the fact that if two vectors are identical, they must have the same magnitude and they must have the same vector. Now, to define a vector, you must allow it to possess some magnitude, give it some direction, and also ensure that it satisfies the triangle rule. And the last point that we discussed was the fact that a triangle rule is the same as the parallelogram rule. The parallelogram rule is basically if you want to add two vectors, A and B, you draw them as two sides of a parallelogram, and the resultant turns out to be diagonal of that parallelogram, emerging from the side at which from the vertex at which both the vectors originally are placed. So that is to tell you how we can add two vectors. So I hope this video made sense, and I hope it helped you, and all the best.